Okay, recording has started. So welcome to today's class. We'll be going through functions in C++. So functions are this practical should be somewhat straightforward. Like it shouldn't take you a lot of time to do it. But since I couldn't find a past practical that I can use to demonstrate um like to actually solve a practical using functions. So I'll just make examples using functions. I'll explain the different types of functions that you guys are required to use in this practical. So I'm going to open code blocks. Let me see. Just checking because sometimes I connect to my headsets and I forget to disconnect and sometimes doesn't record the audio. Yeah, it becomes a mess. So console application, Vortex Academy, computer science 1A. Today we're talking about the introduction to functions, right? And then I'm gonna save it there. Then I'm gonna go to view and then manager sources main.cpp. I'm starting not to like this. Let me try to check if this thing can locate. Okay, just give me a second. I want to change the theme for my code blocks. Open file location. Okay, so I think it's inside roaming. Yeah. So app data roaming code blocks. Okay, so I found it. So I'm going to click here and then go to C drive and then users and then app data and then roaming and then code blocks. Then there's the file. Then I'm gonna load that file that I downloaded, the theme.conf. Then I'm just gonna select every theme from there. Okay, and then I'm gonna click transfer. Then I'm gonna say yes, then I'm gonna say okay, then I'm gonna say save, then I'm gonna say yes, then I'm gonna say okay. And then close. Then I'm gonna restart code blocks. Then open code blocks again. Now we should have the themes, right? So this is the recent project. Um, Seems like it didn't do the right thing, but we'll see. So I'm gonna go to settings and then editor. And then go to syntax highlighting. It didn't change. How come? That's weird. Yeah, that's weird. Let me let me close it again. So let me go to file and then close project, then close code blocks. And then let me try it again. So it's inside down C drive users and then app data, roaming, code blocks. There's the file. Right, then I'm gonna go to my downloads, take the theme, the code block. Okay, so select all of my colors, my themes. It should have worked. I don't know why it didn't work. And then I'm gonna transfer, then okay, then save, then save, and then okay. Then yeah, I don't know why it's not doing it. It's if it's not allowing me to change the theme, then it's fine. Okay, now it decided to behave. So I'm gonna go to edit. This is not my cup of tea. I like the KFT2 theme, and then okay. So yeah, so let's talk about functions, right? Sorry about that. I just wanted proper theme. So let's start. So what are functions? Functions, they're basically similar to functions in maths, right? If you remember in your maths class, right, you'd have f of x is equals to something. Let's say, for example, f of x is equals to x plus 2, right? So this would be a function, right? Then, so basically, this is a function which, so it's called f. That's the name of the function. It takes in the value x, right? And this is what it gives you back. So when in maths we just say it's equals to, but in code we say that this is what the function returns. This is what it gives you back. So that's so basically if I have f of 1 like this, if I'm trying to find f of 1, that means, and I want you to notice something here. This first step declares the function basically and gives it a formula or something that it should give you back. And then this is the second line. I'm now using that function. So if x is equals to 1, that means if x is equals to 1, that means f of 1 should give me 1 plus 2, which is equals to 3. So that means in a way f of 1 is equals to 3. So if you still remember in high school, this is how we were doing functions, right? But then in C++, it's still similar, but then in C++, there's a slight difference, right? There's a slight variation. But in simple terms, that's what functions are. We just like in your high school when you did functions, you put in a parameter. Here we call that a parameter or an argument. But in this case, we call that a parameter. And then when you call the function and you're passing a value, that the value that you're now passing, we call that an argument, right? So this is basics of functions, right? So I want to explain something we call scope. I think if I explain it in this way, you'll understand functions a bit better. So there's something called scope. So scope is defined by what? Curly braces. So in C++, you can define scope by putting curly braces. The curly braces, it means that anything that's part of, basically curly braces, they just mean that anything that's within these braces, they only exist within those braces. So I can write a whole full for loop here and then output something, right? Or I can, for example, let me show you how scope works. So let me create a variable and I'm going to call it number. Then I'm going to initialize it to like 20. So this is another way of initializing, right? We call this, I think it's called list initializer, right? This is another way of initializing your variables. This curly braces around 20. It's the same thing as saying is equals to 20. It's basically the same thing. You just like everything in life, there's always multiple ways to solve it or to do that thing. So the same reason why there's multiple ways of doing something, even in C++, it also has multiple ways of doing something. There's also the round brackets if you want to initialize your variables like that. That's also fine. But then I prefer curly braces. Why do I prefer curly braces? Because if you pass here something that's incorrect, it's going to give you an error that's proper. Because whatever you put within the curly braces, it should match with the data type here. So you can't come here and then you put a string. Then there's a problem and say hello. Let's try to build it and you see that it's going to give me an error. As expected, it gives me an error. So I don't want manager, I want the logs. So I'm going to show you the error, right? You see that the error, it kind of becomes a bit easier to read instead of when you just use that equal sign. It's telling you that it failed to convert the const char pointer to an int. Const pointer is basically the string. It's telling you that you failed to convert the string to this int type, meaning that you basically passed in the wrong thing that C++ wasn't expecting. So that's why I like Kelly list initializer braces. These braces here, they give you a meaningful message when an error occurs. So there's the number, right? Then I'm gonna try to output the number, right? Simple, just a simple application, right? So cout number, then I'm gonna add an end of line character, right? Simple, straightforward. This code is going to run, right? Perfectly fine. There's that number, 20. This code runs because everything, remember what we were talking about scope here. Scope is defined by Kelly braces. So this integer over here, you see that it's in between these braces here, or these brackets here. Even the cout statement is within these braces. The moment it goes out of this braces, you see, the moment you do this, remember the int number, it only exists within these braces. So the moment you try to do that, let's try to just build an error occurs. And then it's going to tell you number is not declared as expected. Number was not declared. Because you see, I want you to look at this term scope. Look at what it says. Error number was not declared in this scope. So it's telling you about scope, of which that's something we're talking about here. So it does not exist in that scope. So that's why I put a cout or an output statement within this Kelly braces, because this number here, it was defined within this scope. So this would be what we call the start of the scope. And then this would be the end of the scope. Then within those Kelly braces, you can have any amount of code. You can have for loops, you can have switch statements, anything that's a C++ statement. That's a valid C++ statement. As long as you use if you declare variables within those within that scope, make sure you use that variable within that scope. Because if you go outside, then it's gonna show you an error because the variable is only defined within that scope. So since we have something that we call scope, I'm sure now you can see similarities between these Kelly braces. You see, I have Kelly braces for what? For function here. There's Kelly brace opening, and closing one. So can't you see that it's a bit similar to this? The only difference is that they've given the scope a name. Remember, within a scope, we can put any code. So what if I want to define code in a specific scope, and then once I've written that code, then I give it a name. Then I use that name to I tell C++ to go fetch that code under that scope with that specific name. In order to achieve that, we need to use what I call functions. So functions, to declare functions, right? Let me give you how to declare functions, right? So the way you declare function, right? You type in the return type, right? Meaning the data type of basically what type of thing does your function give you back? And then followed by the name of function. Pay attention to spaces. You see the spaces that I'm using here. Pay attention to those spaces. And then space. Oh, okay. It's a return type. Yeah, it's okay. I'm thinking about the different programming language right now. Let me bring back my mind. Yeah, it's return type and then name of function. And then you're gonna have your parentheses here. Then you're gonna have your parameters, right? And then when you put a semicolon like this, right? When you just declare the function like this, we call this the function prototype. But if you define it again, but then instead of that semicolon, you put in the scope, which is the Kelly braces, right? When you do it like this, that's now what we call the function implementation. Basically, you've implemented the function. This function prototype over here, this part, this section, was simply stating that this is the signature. That's how the function will look. That's all it was telling C++. But then it's like you're making a promise to C++ that listen, C++, I'm gonna create a function like this that gives you back specific type, and then it's gonna be called this. It's gonna have these parameters. So for now, don't worry about what it does. Just know this is how it is going to look. So the way it looks, we call that the function prototype. So this is the function prototype, right? And then over here, the one at the bottom, this will be function. This will be the implementation. Let me not just call it implementation, right? That's because if you check I think it should be there in your practical. Yeah, you should make use of prototypes. You see, so yeah, and prototypes, you always define them outside of main, but above it, right? Meaning outside, so starting from here, that's where you define your function prototypes. So I'm gonna put a comment here and say function prototypes. Since we know data types, right? Remember the return type here that you're gonna use. It's any valid C++ data type. For example, int, double, string, char. That's what you call. That's the return type I'm talking about here. So we already know those types, right? What we need to fully master is this type called void. There's this type called void. The way I want you to picture void, I always make this example. I don't know how many years I've been making that same example. I don't know. I think since 2019 or 2020, somewhere there. So the way I like to view void, right, is by making an example when you go to Pick and Pay or Woolworths or whether you're a rich kid, an average kid, wherever you go to get your grocery. So it doesn't matter where you go. The main point is what happens when your card declines. What does the cashier say? Remember when your card first declined, you went there, you were confident, you got there, you swiped, and then decline. If you went to places like Abo Shoprite, that's when they call Abo Prudence. Prudence, yeah, decline, avoid. They talk to their fellow employees in the shop. They tell them void, it's declining. Void, it means nothing. We got nothing. So void just means there's an absence of a value. That means there's nothing. It's void. Just like when your bank card declines. That means they were not unable to extract the money. So they got back zero, nothing. So think of it in that way. Void just means this function doesn't give you back anything. So that's a type that you need to be aware of. Yeah, so I'm gonna create a function prototype. Remember, we talked about f of x, right? So f of x, that function. So I'm gonna use that same example, but then in code, right? Remember, we talked what's the structure for a function prototype? You type in the return type, followed by the name of the function, parameters, and a semicolon to terminate the statement. So I'm gonna put a semicolon here. The return type, excuse me, what is it going to give you back? So if I'm taking in an integer, remember our example, it was f of x is equals to x plus 2. So if I was to say f of 1, right, you see I'm passing what? An integer. And then I say 1 plus 2 is 3, which is another int. So in C++, you have to be very explicit. It's not like languages like Python, whereby you can omit the type and things like that. No, C++, you need to put the type. So you need to type in what does it return. It returns back an integer. This is the name. I'm just gonna call it F because I want you guys to sort of like see that it's similar to maths, right? To get that whole idea. And then parameters. Yeah, remember the return type, you can also not return anything, just use void. But in this case, I'm going to use int because I'm going to return back an integer. Then you must also tell C++ what data type will it take in. Remember, this x is an input. This is what comes into the function. So a simple demonstration, right? Damn, I deleted it. Let me open the browser and then I'm gonna say draw.io. I'm gonna show you an example of how a function actually works, right? So a function, you can think of it as like a magical machine, right? Whereby it takes in something and then it spits out something. So just like, I don't know, maybe at a factory whereby they're making cold drinks or fizzy drinks or whatever. They start with empty containers that enter into the machine, and then those empty containers at the end they end up having what you call the fizzy drink, right? But I want you to view it in this way. If you did, I don't know whether was it commerce in high school. I think we were taught this thing in commerce. I don't know whether it's economics or I don't know. Because I did commerce, so I can still remember. Or maybe it was also from like secondary, like grade 9, grade 8. I think grade 8, grade 9, they did talk about it. So if you still remember this three-way process, right? You should definitely remember, even if you have bad memory. We have input, right? And then we have process, and then we have output, right? So this is exactly how a function works. But then, like I said, not all functions give you back an output, and not all functions take in something. So I'll just make this one purple. So this is sort of like the process, right? So inputs, right? These are the things that this is information that's entered into the function. Then we pass it into the function here. So the process part, that's where the function does these things, right? So it processes the input. So this will be f of x based on that input, right? So f of input. So f is the name of the function. In brackets, we pass an input into the function. Then process is where the function is processing, calculating. Once it's done, it gives you back output or a result. And it can give you the output in different ways. For example, it outputs to the standard output stream, meaning we use cout, or it literally gives you back the value. So there's multiple ways of doing it. So we get inputs. In this case, in the example that I made, int x is my input, right? And then the process, okay, I need to phrase it a bit different. The process is x plus 2. That's the calculation that takes place. That's the process. Then what you get back is the same thing, is a value x, is the x value incremented by 2 or with 2 on top of it. So for example, if you enter 2, the process part is going to say 2 plus 2, then give you back 4. So that's pretty much the whole process of a function. That's how it works. That's literally what a function is. So here, like I said, in C++, you need to be specific and tell C++ that what data type are you taking in? What is your input's data type? So my input's data type is an int. And I know you are used to declaring variables and putting semicolon after declaring. No, don't do that. That's very spiritual. It's not going to work. You must put the data type like this and then comma if to add more, because you can have multiple inputs. So maybe int y. So you take in x and y, or you only take in x. You can have multiple inputs. That's up to you how you want to structure the function. Then now you've told C++ this is how the function will look. That's the function prototype. Then now let's build the function, right? Let's implement it. By implementing it, right, we are actually doing this part, the process. That's what the implementation is for now. Function implementations. Then I'm gonna copy the same function, then remove the semicolon. Then it's up to you how you want to put the curly braces. You can put the curly braces like this, and then you start typing here. Or you can put them straight like this. That's up to you. Me, I like to put them straight like this. It doesn't really matter in what way you put it. Still the same thing. So remember our formula, right? It should give us back x plus 2, meaning give us back the parameter and then add 2 to that parameter, give us back that result. So how do we do that? There's a keyword in C++ called return, which just simply means give the answer to the person calling the function. So it just gives you, it just returns, it gives you the answer. So it's like, for example, if I told you to write down the answer for 1 plus 1, take a pen and paper and write down the answer for 1 plus 1. Once you've written the answer for 1 plus 1 on the piece of paper, hand me the piece of paper. So that process of you giving me or handing me that piece of paper, you are returning the answer. That's exactly what the function does. So how do we return? We simply say return, followed by what the value that I want to return. I want to return a value whereby I take this input, this parameter x, added by 2, and then done. In this case, it's a simple function, right? I don't have too many things. But then just be very careful with the return. Return, it does two things. It gives back, it terminates, it exits the function immediately. It's like break. If you remember break in a switch statement, remember if you see, if you put break in a switch statement, when break encounters that, when the switch statement encounters that break keyword, the switch statement immediately terminates, it stops. So the same applies with return. Return works in a similar way for functions. You can use return. When you use return, it immediately leaves the function. After immediately leaving the function, it gives you back a result. Since it gives us back a result, we can call this function and then store the answer in a variable. So now I'm gonna go to my main function. Then I'm gonna say create a variable called answer. Then I'm gonna say is equals to f of. So now I'm calling that function. Now I need to provide it a value here for x. So let's say f of 10, right? Semicolon. Then I'm going to say C out, and then it's going to output the answer, which should be 12. Because do you know what happens with the function? The thing is, I don't have a very good laptop to demonstrate and draw and things like that. If I had a MacBook, then yeah, I would demonstrate. But yeah, I don't have the resources to be explaining in a detailed way. Because with the MacBook, I saw they have a feature where you can install something whereby you can draw on the screen. I've never seen it on a Windows, but a MacBook I've seen. I'll see. Maybe it's there for Windows, but I've only seen it for a MacBook. So what happens is that when C++ reads your code, right? Remember, it reads from top to bottom. It sees this function prototype, then it sees, oh, that's a function. Then it goes to int main. Then it looks at here. It tries to check if this matches with this, meaning the data type that you've passed doesn't match with this data type. And the variable you've declared to store the answer, does its data type match with the return type of my function? If that's true, then cool, we're good to go. If for some weird reason anything is wrong here, it terminates with an error. So yeah, you need to be very careful with functions. Then I'm gonna build and run. So there's my value, 12. Right? It gives me back the answer, 12. Then I'm gonna demonstrate something else now. So what did I want to demonstrate? Uh, so yeah, that's the whole flow of a function. Then you can have, it's up to you. Remember, functions are different. You can have a switch statement here, whatever is valid C++ code. You can have for loops here, while loops, if statements, and then within the if statements, you have for loops. It doesn't really matter. As long as if you said your function returns something, it should return something. In this case, it's a simple function that calculates. I'll share the code in the group, right? So don't worry about that. So now let's talk about the different types of functions. So which function have I created so far? We created what we call a value returning function. You see the word, it's actually self-explanatory. It returns, you see, meaning that it is that return keyword. And then if you check my function, you see, there's that return keyword. And I hope now you can see something with the main. Do you see main function? It returns an int, and we return 0 here, an int. If you didn't notice, but yeah, main is also a function. So if you didn't notice, so I'm gonna go back to the document. So that's a value returning function because you see it returns some value, right? Meaning we've answered the first question in a way, right? For me, it's a simple application, right? It's just adding 2 to the current variable. Then we have a non-value returning function using an argument that is passed by value. So that means you should create a function that does not return a value, meaning use void. So let's create a function like that. So void, I don't know. What am I gonna call it? I want to keep things simple. So let's say this function, it using an argument. Remember we talked about parameters and arguments. If you've if you've created a variable like this, right? And you see the function, the variable, the variable inside the input section for the function, we call that a parameter, right? You see X here, we call this a parameter. But when you use and you call the function, the value that you're passing, we call that value an argument. So in this case, 10 would be an argument, right? That is passed into the function f. Then I'm gonna have function, I'll just call it print, which takes in the value x. So they said by value, right? Passed by value. So what is passed by value? What is passed by reference? So I would have to talk about pointers, but I won't touch on that because you guys are not there yet. Once you're there on pointers, you'll know when you do game development. Yeah, it's gonna go down there. You're gonna have a lot of code and a lot of functions. Yeah, so you guys better be prepared. So a value, a function whereby you pass by value, it means that you pass by the actual value, not by where the value is stored. So in a computer, right, every variable that you create, so there's something called the stack, right? So inside this stack, a stack, just view it as like a waiting area or storage area, like a garage where you park your cars, or fridge. So that's the one you picture a stack in that way. We have a stack and a heap. Heap, you focus on them in second semester when you do OOP. Even now, okay, even this semester, we'll talk about heap memory. Yeah, I will have an in-depth session on that. But I do have a video on pointers, so I think I can send you that link so that you guys can know more about pointers in C++. So what happens is that I want you to view, you see memory, right? There's this thing called main memory, which is RAM. So RAM it is like blocks like this, right? There's multiple blocks. Then what happens is that when you create a variable, the computer, right, it chooses a random box to store that value for that variable. So when you store that value for that variable inside the random box here, each box actually has its own address, right? So you can find the address for that box in certain ways in C++, or you can yeah, there's ways to find the address of that block, right? So for example, let me comment out here, right? Um, okay, it's fine. So to find an address for a variable, when you send to output, right? When you send to the output stream the value, you're gonna use this ampersand, right? This is what we call the address of operator. It gets the address of a specific variable. So you need to put it in front of the variable name. So what is an address? Like an address of where you are staying right now, right? That's literally an address. So like I said, computers, they always copy the real world, which is Earth. Whatever we're doing on Earth, computers copy that because they were made by human beings. So they borrowed the concepts that we have in the real world and put them in a computer. So if you understand an address For example, if I want to go visit a friend, I would ask them to send me their like Khalid once said, send me your location. So I'll ask them to send me their location, which is their address. Then I can know where they are located or where I can find them. So in C++, it borrows from that concept. Every variable, even functions, they have their own addresses. But then functions is a bit advanced. We will never talk about function addresses. Let me think about it. Let me try to phrase that. Yeah, maybe second semester, first practical. When you're talking about function pointers, yeah, first practical, function pointers, yeah, you will talk about, yeah, but it's very kind of complicated to think about it. But it's not too complicated. If you understand the addresses of variables, you can simply extend from that. So to get an address for a variable, I just put that ampersand in front of the variable name. Then that's going to output where that variable is located, its address. So if it's 36th Avenue, then it's 36th Avenue. In this case, computers they store addresses using hexadecimal. You wrote semester test one, you know what hexadecimal is. So it stores the addresses using hexadecimal. So you see, there's the address. So you can so basically in functions, that's why they're talking about pass by reference, pass by blah blah blah. So you can actually, when you look at when you see this, right, we call this pass by value. It means that you're literally passing the value, which also means that if I make changes to this variable in the function, those changes won't affect, they won't go beyond the lifespan of the function of the function. So what do I mean by that? So let's try to implement the print function. So void print, which simply takes in the value x to print, right? So cout print x and then end line and then done, right? Simple. I'm making very simple examples here. Then instead of me always typing cout, I'll just simply call print. So print, and then I pass the variable I want to print, and that variable needs to be of type int because that's what you said when you're creating this function. The data types need to correspond. Computers, they're very, very hardcore. They're not gonna let things slide. They won't let things slide. So be very careful. And remember, the function does not return anything. So I don't do spiritual things and try to say answer is equals to. It's gonna crash because it's gonna be like you use void. It means that, yeah, I'm not expecting anything. So why are you trying to get back nothing? Because nothing is returned. So it makes no sense. So it's like you're trying to leave Pick n Pay with the grocery, but your card declined. So they got nothing. So what are you trying to do? That's impossible. You can't get that thing that you wanted without by giving us nothing. Because this function gives you back nothing. So you can't put it in a variable. That's impossible. Even an error is okay. Void value not ignored as it ought to be. It means that you didn't ignore this void. You're supposed to ignore any functions that return void because they don't return anything. Here you didn't ignore it. That's what it's telling you. That basically you're stupid. That's what it's telling you. So make sure any function that's inside that's declared with void as its return type, it shouldn't have an equal sign behind it here. No, don't do that. It doesn't return anything. It simply does something. So if I run this, it will still work exactly the same way, but under the hood, I've now introduced a function that does that for me, which actually it's kind of like cool because let's say I want to print another variable. I can just simply say print. So I don't have to always type cout, blah, blah, and then, so in a way, it kind of helps. So I was talking about what happens when you change the variable, right? So let's experiment. Let's do some experiments. So let me output this variable. Let me display this variable, right? But then before I display it, let me change it to 10. So x is equals to, and let me change it to um 123. So you see that I changed it to 123 before outputting it. That means the answer that will be displayed here is going to be 123. But then what happens is that if you're passing a variable by value, what happens is that the changes that you've made, remember the curly braces here, they only exist within the scope. The moment you leave this function, the variable goes back to its normal value. So if I go back here, you see print is now going to print 123. But if under here, I try to use cout and I say cout answer, you see that answer is actually still 10, but you ask yourself, but I did change it in the function. Well, what happens is that if you pass this, if you use pass by value, you get a copy of the value. So here you're changing a copy, not the original. So yeah, just that's something very important to understand. So I'm going to build and run, and you see that my output is going to be 123 and 12. So this was me after changing it. This is me checking the value after calling the print function, which changed the variable. But then wait, the variable is still 12. So that means it didn't actually change it. It was a temporary change because when you pass by value, basically, how do you know you've passed by value? If it didn't say address of here, if you didn't put address of there, that means you passed by value, meaning you made a copy. Then I'm just gonna remove this. Okay, it's fine. Let me leave that. Let me leave it there. So I'm gonna output here and say cout after changing the variable. Output should be that, and then here I'm just gonna say cout. Yeah, I'm gonna change. No, I should say. I'm just gonna say here. I'm gonna say changed the x variable to. Then I'll put the value that it was changed to. Then here I'm gonna output after changing it to check if it's still the same value. So I'm just I'm just making my output look pretty and understandable. You see, we changed x to be 123, and then after changing it, it's still 12 because we are passing by value. We're passing by a copy. When you use addresses, right? I want you to think of addresses like in the real world. For example, if someone gives you the address, right, and they give you the address, don't you have access to where they physically reside? You have, right? That means you can make permanent changes. What do I mean by permanent changes? You can go to their house and then go inside their fridge and then eat all of the food in the fridge. That's going to affect them because you now have access to the address. That means you go direct to the original, which is the original, right? So I want you to picture it in that way. So if you pass an address, just know the changes you make in the function or pass by reference. Another word for address is in coding they say it's a reference. So address or reference. So when you pass by reference or by address, just know the changes you make within that function, you are affecting the original, not the copy. You're working with the original. So let's test that out. So if I create another, and they said, if you check your practical, right, they said another non-value, that means it should return void. It doesn't return anything. And then you use an argument that you pass by a reference. So I'm just going to create another function called print version 2, right? It's a function, it's a printing function, but it's version 2. This one takes in the original, which is x, right? So it takes the original, which is x, then by address, right? You see, by reference, meaning I'm going to go to where that thing actually resides, meaning it's original. I'm not going to be working with the copy. Then I'm going to copy this, scroll down here, then replace the semicolon with curly braces. And then since I'm working with address, I'm just going to repeat this exact same code to show you the difference between pass by value and pass by reference. So if I try to print, right? So This is using pass by, yeah, let me just sort of phrase it. Pass by value. Then I'm just gonna put two end of line characters. Remember, \n just means end of line, right? Then after display, after changing it, then here I'm gonna output just to format my output, right? So end of line, and then insert another end of line character. This is just making the output beautiful. You see from here, I'm just making the output beautiful. That's all. Nothing too fancy. And then pass by reference. I have experience, so I can picture this code in my head. So I know I know how it's looking as I'm typing. I can see the output as I'm typing the code. So you will see the output. So here I'll pretty much repeat this, right? To show you that answer does change when you're using pass by reference. So here I'm going to explain, put a comment here that says testing pass by reference. Don't worry, I'll send you the code in the group. So let's try to print, right? So print the value. So print version 2, that's the function. It needs to pass in a value by reference. So I'm gonna pass the same variable answer. And then you see that now it's going to change permanently to 123. Hopefully it does. I hope I don't have to, I didn't forget this thing. See out, blah, blah, pass by reference. And then after changing it, um, okay, so let's build and run it. Let's see. Yeah, so 100% correct. So as you can see, it was, okay, I made a mistake a bit. Let me fix that. Let me fix this. Let me put this over here, right? And then I think that should be fine. I want you to notice something, right? When I pass by value, right? Meaning I was working with the copy. I changed it in the function to 123, but when I was outside of the function, the value was still 12. But then when I pass by reference, meaning I pass by by its address, where it's physically located, that means I literally went to where it's located and took the original. So when you change it in the function, it became 123. Outside the function, it's still 123 because why? I went to the physical location of where that object is stored, right? Which is the integer. So that's the difference between pass by reference and pass by value. So for you guys, it's going to be slightly different, but it's pretty much the same thing. So when you pass by reference, just know that whatever changes you make in the function here, they'll persist. They'll go beyond the scope. Remember the scope here, this curly braces. The changes you make here, they'll actually persist. They'll go beyond the scope. And then here, since I'm working with pass by value here, whatever changes I make here, they'll only be limited to that scope. That means once I'm outside of this function, that value that I've passed, it goes back to its normal value, to the way it was. So yeah, that's pretty much functions. And then one key thing, one important thing, right? In functions, you see that the function does not return anything, but you're allowed to use the return keyword to leave the function. So if you use a return keyword and you have no value here, just return keyword, this actually tells C++ compiler to leave this function, right? But then this should only be used, I don't know, maybe, how do I put it? Maybe if the value you've passed, maybe we were expecting a positive number. So we're just gonna have a check and say if x is less than 0, that means it's a negative number. We simply just return. We leave the function. We don't change the values. So I'm gonna do that. So we simply just return, meaning leave the function. So you can do that, even though the function says you shouldn't return anything. You're not returning anything because why? After the return keyword, you didn't specify a value. So you are still following protocol. So let me test now. Let me change this to a negative 10, right? So that my number is negative. You see that print here, right? It will not print the number. It will only show after changing. Why? Because in my function for print, I said if the number is negative, leave the function. That means any line after return will never be executed, even if you pray. No such miracles will happen. So you see, pass by value. You see that it didn't display inside the function because I put a check, the condition to check if the value is less than 0, simply leave the function. So that's something that I think you might need. You might need to know. And also, before I forget, you can specify default values for parameters. So you can say if the user doesn't enter anything, right? So it's going to be 40, right? You can do that. Let me just double check. I tend to do a lot of languages and forget. Okay, yeah, it is compiling. So you can initialize, give it an initial value, meaning that means, you see, when you give it an initial value like this, it means this parameter is optional. So even if you don't pass it. So how would you call a function without passing the parameter? You simply remove the parameter like this. So why will this work? Because I told C++ that if a parameter is not provided, initialize it to 40, initialize X to 40. So you see that if I try to build and run, it should run. Oh, I think I was also supposed to define it here. I don't like this thing about function prototypes. Yeah, function prototypes, they mess up things. You can do this. The thing is, I'm forgetting syntax. The argument for given for parameter of 1 point int, no previous specification. Yeah, I forgot. I would have to double check on that. I forgot the syntax. Right now I'm busy, I'm heavy on Java right now. But it is possible you can do this. But then I think when it comes to function prototypes, I think it's slightly different. Let me see. Let me try to remove it here. No, what's going on here? Oh yeah, it's working now. So when you have function prototypes, right, just only initialize it in the function prototype, right? So I'm gonna change this a bit, right? Let me remove this so that you see that is gonna output 40. So I'm gonna comment that line out. You see that this will now output 40. So I'm gonna build and run, and then you see there's that 40. So you can make parameters optional in C++. So yeah, that's it for today. That's all I have to show for today. So if you have any questions, just know you can ask in the group. I'll respond to the questions. So this is basically how you guys should do it for this practical. It might depend on what value you're returning. In this case, my function returns an int. That's the example I chose to use. Yours could return a string. That's also fine, as long as it's a valid type. So just gonna leave it like this and then send you the code. So that's it about functions. Thanks for watching. See you in the next tutorial.